All right, welcome back to the second part of our vector tutorial. I'm going to start right where we left off from the last one, from installment number one, and move into this problem. What are the components of the vector below, and what is the resultant? So we're going to jump in and we're going to work on this part right here because the other part's pretty simple. So if we jump right in and look at this magnitude of the hypotenuse, we can say that we need to find the y component and the x component. If we're looking for the y component, we can say y is equal to 7 times sine theta. So y is going to be equal to 7 times sine 25 degrees. So y is equal to 7 times sine 25. Y is equal to 7 times sine 25 degrees. Whoa. This is a little harder to do on the board. I get a little carried away here sometimes. 7 times sine 25 degrees equals 2.95. Y is equal to 2.95. Now let's look for the x component. The x component will be equal to 7 times cosine theta. So x will equal 7 times cosine 25 degrees. X is equal to 7 cosine 25. Let's take a look at that. 7 times cosine 25 is equal to 6.34. So x is equal to 6.34. All right, I'm going to box those so we don't lose them here. All right, now let's look at what we really have going on over here. If we look at the x component, then we have 4 plus 6.34, which equals 10.34 for the magnitude in the x direction. And for y, we're going to have 5 plus 2.95. Kind of running out of room here, so let me shrink this up a little bit. Maybe. All right, scoop this out of the way. All right, so the y direction we had 5 plus 2.95. So the total of the magnitude in the y direction was 7.95. All right, now if we want to find the resultant vector of everything that's going on here, it's kind of what we've been doing. We need to go from the tail of the first one to the head of the last one. And now we just use Pythagorean theorem again. All right, let me just get this out of the way so we can work over here. Alrighty, so c is equal to the square root of a squared plus b squared. So c is going to be equal to the square root of 7.9. Well, let's see, either one, doesn't matter. They can both go in there. 7.95 squared plus 10.34 squared. 34 squared. All right, so c is equal to, get the calculator back out one more time. Calculator. All right, we've got 7.95 squared. 95 squared, 63.2. And 10.34 squared. 10.34 squared is 106.9. 6.9. So c is equal to the square root of, let's see, 63.2 plus 106.9 equals square root 13.04 units of whatever. So 13.04 units here. And if we want to know what this angle is, angle theta, we can figure that one out too. This is not too bad. All right, what would the angle there be? So this angle would be, let's see, the tangent of that angle. Tangent theta is opposite over adjacent. So tangent theta is going to be equal to 7.95 divided by 10.34. 7.95 divided by 10.34. Alright, so inverse tangent is 7.95 divided by 10.34. Oop. 7.95 divided by 10.34. And get an angle of 37.55 degrees. So this angle is, what did we just say? 37.55 degrees. Alrighty, got that one done. Alright, so got this done. I'm going to hustle here because I got about 8 minutes left. I don't want these videos to take forever. Let's work a couple of story problems here. Let's say we have a helicopter going 95 kilometers per hour, an angle of 35 degrees to the ground. What can we do about that? Well, the first thing we need to do is draw a picture. Alright, so let's do that. Let me find my arrows, get everything to cooperate over here. Alright, we were traveling 95 kilometers per hour, an angle of 35 degrees to the ground. And you know what we're going to have to find here are the component vectors. Alright, X and Y components of this. So let me get something here where we can look at this. You know, we need to find this X component and this Y component going up. Let's make this velocity here is 95 kilometers per hour, and we're looking for velocity Y and velocity X. So remember that sine theta would be opposite over hypotenuse, so that'd be the velocity of Y over velocity, and cosine theta would be the velocity of X over the hypotenuse. So jumping right in here, let's find the velocity of Y component. That'd be V sine theta. So velocity of Y is going to be 95 kilometers per hour times sine 35 degrees. We've got to put this in here because it said we were 35 degrees to the ground. So sine 35 degrees. Alright, so the velocity of Y is 95 sine 35. Get the calculator out. So we have 95 times sine 35 gives us magnitude of 54.48. Velocity of Y is 54.48 kilometers per hour. Alright, I'll make myself a little bit more room here. And let's whip out the X component. So the velocity of the X component is going to be the tangent velocity times cosine theta. So velocity of X is 95 kilometers per hour times cosine 35 degrees. So velocity of X is 95 cosine 35. 95 times cosine 35 degrees. And let's see, you got 955. That didn't work. 95 times cosine 35 degrees. I'm getting a little too excited here, looks like. Alright, here we go. Maybe this looks better now. 77.81. That sounds about right. The velocity of X is 77.81 kilometers per hour. There we go. Alrighty. That gives us magnitude of Y, 54.48. The magnitude of X is 77.81. Now I'm looking at my clock here, and I've got about 4 minutes left that I want to devote to this video. And let's work one last problem if we can. Let's say we have a bow hunter in a tree stand firing an arrow at 30 degrees below the horizontal. So let's kind of go in here and look at this. We're firing at 30 degrees below the horizontal. And let's change that. Let's change the color. 30 degrees below the horizontal. And we've got a velocity of 100 meters per second. Let's see if we can break this into the components. All right, so just to remind us, let's put some dotted lines in here so we can see what we're doing. Now, you know, since we're shooting this arrow down, we're going to have a negative velocity in the y direction and a positive velocity in the x direction. So let's kind of skip ahead so we can get this done. Let's see, we're going to need a velocity of y and a velocity of x. And now it's very much just like the last problem that we did. Find the velocity of the y component. It's going to be 100 meters per second times sine of, let's see, now, the angle. We got to figure out the angle. All right, because is it 30 degrees? Let's think about that for a minute. Because it says we shot this at 30 degrees below the horizontal. So let's see here. This is the 30 degrees they're talking about. And if we remember our geometry, then this is 30 degrees here. All right, so the angle that we have to use is what then? Then this is 60 degrees, isn't it? All right, so the velocity of the y component is going to be 100 meters per second times sine 60 degrees. All right, 100 meters per second sine 60. So 100 meters per second times sine 60 degrees gives us 86.6. 86.6 meters per second is the velocity of the y component. Now remember, we're going downward, so that's going to be a negative 86.6 meters per second. All right, let's get the velocity in the x component now. So we're going to have 100 meters per second times cosine 60 degrees. So the velocity in the x component is 100 cosine 60. 100 times cosine 60 degrees. We end up with an x component of 50. Velocity in the x direction is 50 meters per second. So there's a component of x, component of y. Remember to keep your angle straight. And I think between these two videos, you guys should be able to do all of the homework that I assigned for y'all. There's some more things we have to do, but you watch these two videos and you'll be able to get your homework done and turned in. That's due on, let's see what, on Tuesday and Wednesday, right? So anyway, thanks for watching, and I hope this helps out. If you need some more help, contact me on Edmodo.